Hold on a second. Okay, there we go. All right. Good evening, everybody. Thank you for joining us here with our Boeing Observatory live stream. And tonight it is me and Matthew, the observatory manager. I'm Liz. I am the planetarium manager. And our education manager, Laura, usually joins us on these nights. She is off tonight. So I know I told some of you last week that she would be on this week, but it turns out I was mistaken. So she will be back next week. So nothing's wrong or anything. She just, occasionally needs a night off. So that's all.
I'll just say she's having fun.
She's having fun.
She's
So
having fun.
yes, having fun with the fam. So we do miss her, of course, very much. But she will be back. Actually, it'll be just her and Matthew next weekend. But hopefully you still want to stick around and hang out with me and Matthew because we have some exciting things for you this evening. We are going to focus on Mars because I don't know if you heard, but something super exciting happened just a couple of days ago where NASA landed another rover on Mars called Perseverance, or Percy for short. So we just thought we would do a little bit of a post-landing recap, just some of the highlights of what has happened so far, and talk a little bit about Mars as well. So the other really cool thing is it is finally clear outside.
Yeah.
We've done a lot of these live streams where we've had some exciting things to share with you, and the pesky clouds got in the way, but it is beautifully clear outside, a bit chilly but beautifully clear. So we will be able to share a live stream view of Mars with you tonight as well. The moon is also out, so hopefully if there is time near the end, we might kind of pop over onto the moon and check that out as well. Before we get started, I did want to just briefly let everyone know that there is a 20-second delay between, since we're going through Zoom, there's a 20-second delay between the questions and comments you put in the chat and when we see them. So if we don't get to your questions right away, we're keeping track of them and we will come back to those. If you do have questions or comments, do go ahead and put them in the chat. Please be kind and courteous to everyone here tonight. But go ahead and put them in the chat, and as I said, we'll try to get to as many questions as we can before our time is up. But before we get started, I'm going to turn things over to Matthew because he's going to give us a brief update about what the observatory's been up to most recently. So what have we been up to, Matthew?
Well, first of all, I think that last week I said, whoever's doing the rain dance, stop. And I think whoever out there who was rain dancing has stopped because it cleared up. So thank you, whoever that was. And of course, I'm just joking. But yeah, we have a beautifully clear night tonight. So we're definitely going to have a look at Mars and then hopefully the moon at the end. So what has the observatory been up to this week? So once again, we are doing a lot of virtual field trips and distance learning programs with schools around the state. And this past Friday night, we had a virtual astronomy night with Blaney Elementary in Elgin, South Carolina, and it was awesome. Liz was there. She was helping me out with that. And we also had a NASA Solar System ambassador named John Hodge, who lives in the Myrtle Beach area, and he was on as well, giving a talk about Pluto and then the Mars landing that we'll be talking about with you all tonight. And we showed the kids a live view of the moon from the telescope. So it was a really, really fun night as we connected with one of our elementary schools here in the Midlands. And this coming week, we have, yep, you named it, more virtual field trips. I have how many this week? 4 on Tuesday, 5 on Thursday, 4 on Friday. So that's what, 8? 13. Did I do the math right? Anyway, we're really busy, and it's really wonderful that we're able to maintain these connections with our audiences. That's you all out there, and our school and teacher audiences, even in the midst of this rather challenging time with the pandemic. So, with that said, I am going to pop up a live view of Mars here with the telescope. Let me get that set up here for you. I'm going to share this. All right. Looks like I need to make a little change on the camera here. So here we go. You're going to see the image get a little brighter. Maybe not that much brighter. So this is Mars in our telescope. And of course, this is where all the action's been this week since we've landed Perseverance on Mars. And you will see that in a telescope, in a small telescope, once again, Mars just looks like a small circle or small dot. It's not that large a planet. And because it's not that large a planet, it also doesn't really look that big in a telescope. The other thing we have going on right now is what we call bad seeing. So when astronomers talk about bad seeing, that means that the atmosphere is really unsteady. And that unsteadiness in the atmosphere tonight is what's causing Mars to sort of look like it's dancing around. And it's also causing that sort of little fuzz that you're seeing, especially off to the side. So it's typically pretty challenging to see detail on Mars, and tonight is no exception. It's just such a small planet that it's tough in a telescope, unless it's a really big telescope. Of course, that's one of the reasons we send probes to Mars. So we're going to be showing you some very up-close pictures of Mars shortly. So Liz, are we ready? Shall we turn it over to you and go find out about awesome things that happened last Thursday?
Yes, we can.
All right, I'll turn my screen share off and I'm going to start watching the Facebook comments too, hopefully on my phone, and be watching out for questions. So
We did get a question. If you want to take this one, Matthew, are we going to be looking at a nebula tonight, or is the moon too bright?
we're actually not going to be looking at a nebula tonight. We're hoping to look at the Orion Nebula next Saturday if the weather is clear. So hopefully the weather will cooperate again because we're planning to get a really nice view of the Orion Nebula finally. We're just going to keep trying on the Orion Nebula. We keep wanting to see it, and then it keeps getting cloudy on a Saturday night, but we're just going to keep trying. We still have a good probably month and a half of easy visibility of the Orion Nebula, actually maybe more like 2 months. So we're just going to keep going, keep trying.
Yeah, and usually when we have planets and the moon out, we kind of focus on those objects until the sky is darker to go for a fainter object like a nebula. All right. Oh, this is for you too, Matthew. Why can't we see Mars in red? Why does it look kind of like an orangish, yellowish? Well, yellow, to me, it kind of looks like a tennis ball
Yeah,
bouncing
that
around.
really a lot of that is, I think, the color response of the camera. It
Mhm.
is a red planet, but with the camera, it is showing it a little bit of a yellow color. And I think that's probably just how the camera is responding to the view, especially on a night like tonight when the atmosphere is really unsteady. I
Hey,
am actually trying to find the Facebook feed on my phone here so I can watch the questions.
okay. Well, I actually got that part working to this time. So
Woo!
I can see some of those. All
Let's
right.
see.
So why is the
I
planet
can now see
shiny?
some questions too. Yeah, lots of finally good weather. All right.
Yes, we finally do. Well, why is the planet shiny?
So the planet is shiny. I see that question right here. The planet is shiny because remember, all planets shine by light reflected from the sun. And our moon shines with reflected light from the sun as well.
Yeah, so important distinction. I know we like to bring it up a lot. Difference between something like a star and a planet is stars produce their own light. Planets shine because of reflected light from the sun. Same thing same thing for the moon. So moon also doesn't produce its own light. It does reflect sunlight as well. and enough so that Mars looks like a bright star-like object in the sky. So it reflects enough light to make it look like a star, even though it's not. So not
So,
producing light the same way that like the red orange star Betelgeuse is, for example.
so Liz, we actually already have a question from Sarah Catherine about what does Percy's helicopter do and how does it work? And I think we're going to talk about that in just a few
Yeah,
minutes.
we're gonna get to that. I just wanted to focus on the questions here that kind of relate to what we just saw with that Mars telescope view, um, before I just kind of go off into a different direction here. Does the same side of Mars face us every time? No, it does not actually. So not like our moon, where the same side does face us all the time. All right, I'm gonna share so you can keep those questions coming. Like I said, if we don't get to it right away, we will make note of it and get to it down the line here. But as I go along, Matthew, feel free to interrupt me as relevant questions come on in.
All
Okay,
right.
so hopefully a lot of people out there watching right now tuned in for the Mars landing, which was on the 18th, this past Thursday, and the excitement started around 3:30 p.m. We knew about a half hour later whether or not Perseverance, or Percy as it's nicknamed, made it to the ground safely. So that was really, really exciting. It was definitely nail biting. I don't know if it was as anxious for you as it was for me, but I was definitely on the edge of my seat. It is no small feat to land anything on Mars, and this was the most complicated landing ever. So hopefully we'll see that here in a little bit. So these are just highlights. There are lots of press briefings on NASA and JPL's websites. So if you want to go check out their channels later, you can get all of the details behind that landing and what we know so far. So we just kind of had to pick and choose the most exciting things. I'm going to go ahead and just start with this image right here, which I know has gone around the internet pretty quickly. This picture literally took my breath away, and I know it did for a lot of people as well. So what is so special about this picture? And what's so special about it is this is an actual picture. Leading up to the landing, we saw lots of artistic illustrations, simulations, just CGI, representations of what the landing was expected to go, because it hadn't happened yet. And so you just get so used to seeing all of these just illustrations that it's just shocking to see an image this good that is an actual picture. So this is a picture of the Perseverance rover hanging down from the descent stage, that kind of power pack that was kind of slowing its last descent there onto the surface of the planet. And I do believe, if I remember right, this snapshot, it's part of a movie that NASA's gonna release hopefully in the next week or two. But this is one snapshot where the rover is about 2 meters above the surface. So 2 meters is roughly 6 feet. So for those of you who are, 6 feet tall, I certainly am not. Just imagine if you were standing on Mars, you could literally like reach up and like touch the bottom of the rover. That's how close to the ground it was. And so it's incredible that a picture, I knew the picture was going to be incredible, but it was just this sharp and this good. I mean, it almost looks like one of those just simulations from, those recreate like picture illustrations before of what we expect to see, but this is the real thing. And so that's just the jaw-dropping background behind this picture. And if you kind of look at the picture in more detail, look around the rover, you can see dust plumes and things from those rockets and whatnot. And to me, this is my favorite picture they've released so far. Not the ones on the surface or anything, just because we've never seen anything like this.
So Liz, I see there's a comment here from
Hmm.
Matthew. Just says from sky crane, and that's actually what we call that descent stage, is
Hmm.
the sky crane, as
Yeah,
it
so
lowered the rover down.
you can see those. There are 3 bridles. They kind of look like diagonal lines on the lower part of the screen there. There's kind of that kind of wavy looking cord that kind of looks like an umbilical cord, and that really what is, I think they do refer to it as an umbilical cord, and it's got the wires in it that's sending signals, to and from the rover there. So when they download the images, all those ones and zeros are going through that umbilical cord. But the 3 straight diagonal lines are like the bridles that, the sky crane lowered the rover from, and then it was gonna just gently drop the rover down onto the surface and then release those cables or those bridles, and then the sky crane portion, that powered jetpack, was gonna just fly off in the distance so that it doesn't crash on top of the rover. So the last thing you want is your jetpack to then fall on top of you after you land. So basically, once the rover touched down, those cables were essentially cut, and then that jetpack flew away to a safe distance. But
All right, so
I could
Sarah
frame
Catherine
this.
wants to
Mhm.
know, was that shot from the helicopter, probably the Ingenuity helicopter?
So it was not from the helicopter. The helicopter is called Ingenuity, and if you're referring to the first ever helicopter that's going to fly on another planet, that is actually tucked underneath the rover right now. So the sky crane is the basically the craft that lowered the rover to the ground. So that's different. That was part of the whole landing process. Um, yes. So we'll go to the next one here, but that's my favorite picture. I could frame it. Print it out and frame it. The second one I wanted to print out and frame is this picture, which also took my breath away, although not as much as the previous one. This picture is also a picture, and that's what makes these so incredible. Again, they're not simulations of what you expect to see. These are actual images. This is Jezero crater, the main image in the background. So if you're familiar with what that landing site looks like, you can kind of see the delta over here. So it's kind of at a weird angle, but then there's this inset up here. And in this inset, that is the parachute that was deployed, that needed to start slowing Percy down. So Perseverance came screaming into the atmosphere at about 12,000 miles per hour, and we needed, over the course of about 7 minutes, to go from 12,000 miles per hour down to 0, or slow it down to 2 miles an hour and then gently drop it on the surface. So part of that process was releasing this supersonic parachute. And this image was taken by an orbiter called MRO, which stands for Mars Reconnaissance Orbiter. And I don't know about you, but I realized when I heard the description of this picture, we throw around those orbiters a lot. We kind of take them for granted. There's MRO, there's Odyssey, there's Maven, there's ExoMars, there's other ones I'm forgetting about that have been there a while. MRO is an orbiter around Mars that's been there since, I believe, 2006. So it's about 15 years old. It's a 15-year-old orbiter, and its original mission was designed for, I don't know, 1-2 years, something like that. Here we are 15 minutes later, and it snaps this picture from orbit of the landing. So this is also incredible because it just looks surreal. I mean, we've never seen a picture quite like that. So definitely a first there. So you can see this inset is zooming in on this tiny little square So that's where Percy was heading in this vast area here. And this is kind of zoomed in, so I didn't show the full landing ellipse. The landing ellipse is basically, well, first of all, an ellipse is just a squished circle. So not a perfect circle, but if you take a circle and you squish it a little bit, and it's basically the target. So we wanted to land somewhere within this elliptical region. So our technology is getting really good, but it's not, you know, super precise just yet. So there's going to be a little bit of error. I think this landing ellipse is approximately a few miles in every direction, like 4 or 5 miles in every direction. But that's definitely more precise than Curiosity's landing, which was, ooh, Curiosity was, I can't remember how long ago that was, but we've come a long way since that. And this shows the exact landing spot in Jezero crater. So up to the upper left, you can see that river delta. And then there's some other, you know, smaller craters in this big crater. So Jezero crater, we're kind of zoomed into one section of it. Jezero crater is about 28-ish miles across. So we're just kind of zoomed into one little corner of it right here. And there are just, it's just rich with all these different features to explore. There are mounds, there are ripples, there are smaller little craters here. The delta over here, which is the most interesting part, is about 2 kilometers away. What is really incredible about this is I love this next image, which this is just a screenshot that I took from the press briefing that was on, I think, yesterday. And this shows you, they kind of color coded things so you can get a better sense of just kind of the topography around that landing site. So the other really groundbreaking thing about Perseverance is it was able to kind of steer itself. It was able to, it had cameras trained on the ground, and it was able to navigate itself a little bit and say, oh, that doesn't look like a good landing spot. Let me just adjust my, you know, adjust things a little bit and, you know, go over this way, go over that way. And it was able to do that on its own because we can't do that. We can't fly spacecraft or drive rovers in real time, like with a joystick or anything, because Mars is so far away that the time it takes for signals to get from Earth to Mars and from Mars to Earth is about 11 minutes. So there's an 11-minute delay. If you say, hey, spacecraft, I want you to go a little bit to the left, it won't actually receive that command until 11 minutes later. So a lot of this had to be automated. So, and as I mentioned earlier, it's only 7 minutes from the upper atmosphere to the ground. So 11 minutes is just way too long. Percy basically scanned the area and identified this spot as a safe spot, and we landed. And you can just see how good the technology is, because this green stuff here basically is not a great landing spot. And then this kind of grayish looking stuff over here, also not a great landing spot. So it was heading for this region, and it was able to say, nope, don't land over here. Oops, nope, don't land over there. That doesn't look safe. This looks like the safest bet. And so it found a beautiful landing spot. The ground is pretty flat. I mean, it's essentially completely flat. There's only a 1 degree grade. So for all intents and purposes, that's flat. And again, this is all false color. This is just color coding. So it's not like there's a forest here or anything. I know that's what it kind of looks like. So this is just to kind of color code things to help your eye kind of see where we landed. Okay. This is the first image that got sent back from the rover once it was safely on the ground. This one is it's a little fuzzy, it's small, it's black and white, because the first image you get back is really just, we just needed some sort of confirmation of like, I'm here, I'm alive, here's the proof. So you don't get high resolution images back right off the bat. We just needed Percy to just send us a real quick, hey, I'm here. Look, I can see out one of my cameras. This is out one of the, I think this is the rear hazard cam. It's got these cameras that, it's got many cameras. It's got like 34 or something cameras, but some of those are specifically just to look for hazards as the rover's driving around, which it'll do eventually. And this is one of those hazard cams, and the dust cover is on. And so that's why the image is not very sharp. But this also gave a lot of people a huge sigh of relief, because I mean, it's proof Perseverance is there. And it's a sunny, beautiful day on Mars. And it's really neat to see that first look there. This is the same view, I believe. This is with the dust cover off, and then they got a color image. So this is where Perseverance landed, and you can see there are rocks there as expected, just pebbles and rubble as expected. What's going to be exciting about our explorations in this area is, what are those rocks made of, and how did those rocks get there, and could there be fossilized microbes embedded in those rocks. And so that's going to be the main part of Percy's mission. It's an astrobiology mission. So looking for evidence of past life on Mars. And I always like to make the joke of, although its mission is to look for evidence of past life, not current life, because we're pretty sure there isn't any current life right now. I'm sure that if, little green alien came up and waved at the camera, we might pause and reconsider our mission plan, but I don't think that's going to happen. So this image is also super duper cool. I stared at this for a long time. This is the right front wheel of the rover. So you can see off to the upper left here, you can see the rocks up close right by the wheel. And I don't know what that reminds anybody of. I instantly thought of two things actually at the same time. Kind of a bath sponge or a sea sponge, and also pumice, so volcanic rock. Now the interesting thing is, what I learned from one of the NASA briefings is, whenever I see rocks like this, I instantly think volcanic, like, oh, it must be volcanic. But apparently it's not necessarily volcanic. It could be volcanic in origin. And volcanic rocks end up looking like this when molten lava, cools, and gas kind of bubbles up and tries to escape, and it, creates these little caves or little holes in the rock. So it could be that, but it could also be sedimentary. So it could be material that, just kind of precipitated out of water flow, and perhaps water ate away at certain types of minerals
So Liz,
in
I'm
there.
going to
And
jump in here because we've
mhm,
got a question that's come in. I
okay,
actually answered it in the Facebook comments, but we might
cool,
as well
cool.
get it online as well. My daughter asked, how
Mhm.
many degrees is Mars? I think what they're asking is, how cold is Mars' surface?
How cold is it? It varies, but it's in the negative. I think I see your response about -80. That sounds about right. It's
Yeah, I just looked that
pretty,
up really quick.
it's pretty chilly. It's in the negative tens of degrees, although it does get up to a balmy, I think 32 degrees Fahrenheit sometimes. So I think it,
That's so balmy.
I think it, does kind of overlap the temperatures we experience a little bit, but for the most part, it is pretty cold. The atmosphere is very, very thin, so it just doesn't keep a lot of heat. But Perseverance is equipped to generate enough heat to survive in those types of temperatures, which is also a really cool thing about these rovers. So yeah, so these rocks, they could be sedimentary, they could be volcanic. We don't know just by looking at them. So I know that all of the surface science team and lots of other scientists and non-scientists are really excited to be able to deploy some of Percy's instruments and find out what are these rocks, how did they get there, and that is all part of the adventure. This is a slide I've shown several times, but this is an artist's conception of Perseverance and Ingenuity. And I basically brought this up because of Ingenuity. I know there have been some questions about it. It is the first ever helicopter to fly on another planet. It is tucked away underneath the rover. And so it did actually send a signal back home to JPL to say, hey, I'm alive and my batteries are charging, basically. So Ingenuity is okay. It seems to have survived the landing just as well as Percy did. In that press briefing, they did give a rough estimate of when the helicopter will actually fly. So it'll probably be roughly about 60 sols. And a sol is 1 day on Mars, which is not the same length as an Earth day. An Earth day is 24 hours. A day on Mars is about 40 minutes longer than that. So when we talk about days on Mars, you'll hear the term sol thrown around a lot. So 60 Martian days, 60 sols is a crude estimate. And the reason they can't tell us right off the bat is because there's a lot of things that have to happen before we do that flight. So the Perseverance has to go through a bunch of health checks, make sure, everything did survive landing okay and is working as we expected to. And then it'll do some like a test drive, probably move forwards and backwards a little bit, do a little dance, just make sure, just slowly test everything out. You can't rush it, because if something goes wrong, it's really hard to fix it. You can't just pop on over and fix it. So we want to do this slowly and carefully. And then after everything checks out, they have to go find a place to fly. So you can't just fly it anywhere. You need a big open flat space, kind of like what they have here in this artist conception. This is kind of an area we hope to be able to find a nice open space so that Percy can actually release Ingenuity from the underside. It'll just kind of like drop it off and then slowly back out of the way, just in case things don't go as planned and you don't want our helicopter crashing into the rover. So it's going to back way up, and then Ingenuity will do its test flight and Percy will film the whole thing. Now, the helicopter does have some cameras and sensors on it, so it will try to take images as well. But this is just a test flight. It's not going to do any science. It has no mission other than kind of to be a proof of concept. Can we fly a helicopter on Mars? Because it's got to fly itself. Again, we can't fly it with a joystick from here on Earth like it's a video game. The time delay is about 11 minutes. It's too long. It's got to be able to navigate, fly, land safely on its own. And so it's kind of a proof of concept thing. I do see a question about the the expectancy of Perseverance power source, and I actually do not know that. That's a good
I
question.
will look that up.
And Matthew can look that up.
Yep.
So yeah, I don't. It does not have solar panels. It has a radioactive thermal isotope generator, so it's got some radioactive materials on it that decay and generate electricity. So so it can stay warm, even if there's a dust storm or things like that. So I'm not sure how much of that stuff is on board and how long it will last. But the mission duration is 1 Martian year. But these rovers, and I don't expect anything different to happen with Percy. These rovers tend to last way beyond their initial mission expectancy. So Percy will probably last, I wouldn't be surprised if it lasted a decade, and they probably put enough power on board for it to last that long. Ingenuity will not. I don't know how long. It does have solar panels, but I don't know how long it's expected to last, because it is just an engineering flight. It's just a proof of concept. It's it doesn't need to last decades. Whatever we learn from Ingenuity, whether it crashes and burns or doesn't, that will help scientists and engineers, that'll help them refine their model, so that hopefully we can create some sort of powered, craft like this that can fly on its own over the Martian landscape. And that way we'll be able to reach parts of Mars that are really hard to get to when you have to drive there and go over obstacles. It'd be nice if you just saw like, oh, this kind of looks like a treacherous dune field. Instead of trying to figure out a way around it, it'd be nice if you could just fly over it.
Okay,
So that's,
so I have looked this
mhm.
up. So the rover is equipped with a nuclear power plant that could keep its wheels moving for as long as 14 years, according to an article I just found.
Okay. All right.
So
So my crude guess of a decade isn't too far off.
rover could be
So
going a
yeah,
while.
if all goes well, hopefully at least 14 years. So that's a really good question though. Okay. What I thought, so that's it for those were the most, those are like hot off the press images and things that were released in the past couple of days. I know sometimes people get really impatient with why don't we have the video yet? And the rover also has a microphone, and they were supposed to record sounds of, during entry, descent, and landing and whatnot. Why don't we have that yet? And we have to realize is it takes a while for this data to get back to us. And there are people at NASA and JPL that are literally working around the clock. So after Perseverance landed, there was a team that worked overnight. I think in the press briefing, they said till 5 a.m, so that they could get the images that they did release out to the public as quickly as they could. So they are working around the clock. So if you're impatient to see more, just maybe cut them a little slack, give them a little bit of space. They're probably they probably need to get some sleep, because I know if I was part of that mission, I would not have slept for a really long time. So, and if you did watch the press briefing, what's interesting, and it is recorded, you can go, to JPL's site and whatnot and take a look. And it's interesting to look at the human side of the mission and just see the tense look on everyone's face, even with masks on. I mean,
Oh
people
yeah.
were like sweating and lots of nervous jitters, because they're, it's their baby, and their lives and careers, there's all depend on this going well. So, I definitely, yeah, they definitely, need some time off, but they've got different teams. They're working around the clock. They're working through this weekend to get the next set of images out. There will be a press release on Monday. And I even wrote that down. Monday at 2 p.m. Eastern, there's a NASA press briefing where I am sure they're going to release more images and maybe even video and whatnot. So I plan on tuning into that if I can. And I hope you'll mark your calendars as well, because then you'll get to see those images as they are being released. This weekend, they're also doing health and hardware checks. They're doing software updates. They have to take software off and put the surface science software on, and you got to do that really carefully. As you know, when you do updates on your home computer, on your phone, sometimes things go horribly wrong. So they want to like take their time, do it right, make sure that everything still boots up okay. Then they're also going to deploy the mast. So right now Perseverance is kind of like folded up, and it's kind of like neck and head is gonna unfold over this weekend as well. I made notes of these things so that I don't forget anything. But what I thought it would be fun to do, what I really love to do, is kind of to put this into context. Let me share my
While Liz is
screen.
bringing that up, remember that we would love for you to ask questions in the comments. As Liz is talking,
Yes,
I am watching the comments, so if you have any questions, feel free to shoot them our way.
definitely. Okay, so this is Mars. So hopefully you can see Mars there. This is worldwide telescope. So, but this is real imagery taken from, I'm not sure if it's one orbiter or various orbiters of Mars. And I showed this a little bit in my virtual sky tour that I released, or we released last. But it's kind of neat. Instead of looking at the landing site on just a flat map, I just think it's more compelling when you see it on a Mars globe. And I like to start looking at this part of Mars because to me, it's usually when somebody says Mars, this is usually the image that tends to pop up first. If you're at all familiar with how Mars looks, there's this big gash across the face of the planet that is sometimes nicknamed the Grand Canyon of Mars, Valles Marineris, even though it's not really one canyon, it's a canyon system. Our Grand Canyon would fit into one teeny tiny corner of this. This is about the length of the United States. So that is one seriously long gash in the face of the planet. This is the Tharsis region over here. There are ancient volcanoes up here. But to see where Percy landed, Percy did not land anywhere near the volcanic region or this part of Mars. So, but I wanted to start here because it's kind of a good starting point, which is kind of familiar features to a lot of people. So I'm going to slowly spin this globe around so you can see where we're going. So we're kind of turning the globe a bit, and we are going. So you see we've turned the globe about a quarter of the way. We're pretty much going to the other side of the planet. So where did Percy land? Percy landed over here. And this is something called Syrtis Major. Syrtis Major, Planitia or Planum, depends on, you'll see Planum or Planitia depending on how old the graphic is. This is, I'm not sure if I'm saying it right, but Acidus Planitia right here, a large impact basin. And basically Perseverance landed somewhere along the edge of these two regions, kind of where Syrtis turns into Acidus up here. So we are at about 18 degrees north. I am going to zoom in and zoom in closer and closer and go find out where we landed. And we are right in here. So this is older imagery, so that's why it's not as sharp. But basically there's this kind of snake-like feature here, which is an ancient river or stream that channeled water over this crater. This is Jezero crater, that 28-mile wide, basically depression in the ground that was once upon a time filled with water. And we have already detected minerals there that only form in the presence of water. So we know that this is an ancient lake bed. This was once a big lake. It's now a dried up lake bed. But Percy is somewhere over here to the left, and that big fan delta that's formed when water, kind of comes off of a river and goes into standing water and deposits a bunch of sediments. A lot of minerals and rocks kind of precipitate out of that fluid and just settle onto the ground, and that's what creates that fan-like feature we saw earlier. But even though this imagery is not the sharpest because it's older, I think it's really neat to just put the landing site into the bigger picture and just see where we are on Mars. For comparison, Curiosity, I almost called it Gale. Gale Crater is where Curiosity landed, and it's all the way over here. So if I keep turning the globe, it's like all the way over here. It's over 2,000 miles away. So Percy and Curiosity will never meet up for lunch or anything. They're just too far apart. But if I zoom into here, this is where Curiosity has been working for years now. And this crater is about roughly 3 times larger than Jezero and has this 3-mile high kind of mountain in the middle of it called Mount Sharp, and Curiosity is slowly climbing up that mountain. So it's kind of neat to, again, just see it on the globe of Mars. And if I keep spinning round, we'll come full circle. You'll see Olympus Mons there, the largest or tallest volcano in the solar system. And then we're back where we started. So there is our quick little field trip around the Martian globe.
All right, and I have a question here. What happened to Mars's water?
What happened to Mars's water? So that's kind of what we're trying to figure out. We know that liquid water once flowed on the surface of Mars. We see dried up riverbeds, dried up lake beds. There's evidence of just massive amounts of flooding. So, where did that water go? And part of the problem is Mars's atmosphere, it doesn't have, it has an atmosphere, but it's super thin. And so the water just couldn't maintain, it couldn't maintain standing liquid water on the surface anymore. So why did that happen? And so that's part of our larger history, not just of, think of our history as our history of the Earth, but the history of the solar system. What happened to our neighbor, the next orbit out? What happened? Why did its atmosphere lose so much of its atmosphere, and then hence its water? So what caused that? So that is a bit of a mystery. Okay. Well, if there aren't any other Mars questions, we do have about 10 minutes left here. So I don't know, Matthew, if you wanted to go to the moon or not, or if we wanted to take another look at Mars. It probably still looks like a tennis ball bouncing around.
So while Liz was talking, I actually went into the observatory and went on and moved the telescope to the moon. So I do have a view of the moon right here, although it looks like I need to move the telescope around just a bit and get it actually better placed here. So just give me a second. I'll do a little tweaking here. Right now I can only see like a corner of the moon. And as soon as I get this tweaked, I'll turn on screen share and you can see our view of the moon. So,
and I think it's really neat that we can see the moon and Mars in the sky at the same time. It was cloudy on the night when they were almost right next to each other, but that's because NASA has something called the Artemis mission, which is basically sending the next person to the moon, the first woman on the moon, and putting in infrastructure that will kind of provide a gateway to eventually going to Mars or sending people to Mars. So it's kind of neat that those two objects were so close to each other in the sky. Very, very fitting, I thought. But the day they were the closest.
Here comes the moon.
Okay, here comes the moon.
There we go. And again, as I like to say, when we're looking at objects through the telescope, it's basically like you're looking at the sky through a soda straw. So you're only looking at a very, very small part of the sky. And in the
Nice.
case of our telescope, because our telescope has a fairly narrow field of view and our camera has a really narrow field of view, we can only see a little chunk of the moon. So in a few minutes, what we might do is drive the telescope around and let you see some different parts of the moon. But you'll also see how the image of the moon is kind of jiggling and moving around, and it's like sometimes it's blurry and then it clears and then it gets blurry again and then it clears. What you're actually seeing is, again, that atmospheric turbulence. So the same thing that was making the image of Mars jiggle around is causing our view of the moon to jiggle around. So tonight looks like we have a fairly turbulent atmosphere, and that's not unusual this time of year when we have these cold nights. It's also not that unusual when we've had a weather system move through, which we did yesterday. Um, so yeah, I can definitely see that atmospheric turbulence there.
Although when it goes in and out, but you can at least see craters
Yeah, you can see
and
a
whatnot,
bunch of craters here on the moon.
since the moon
Uh,
is so much closer to us than Mars is.
yeah, the
Actually see
moon.
those features.
Oh yeah, I just clicked a wrong button there. All right, let's see if I can drive the telescope around a bit here, and let's go see if we can find some other spots on the moon. Before I drive the telescope, I actually want to show you the software that I'm using to do this. So I'm going to switch my screen share here. We're going to bring up my telescope control software. So here we are. This is the telescope control software. This is what drives our telescope. And you can see that here on the right, we have this big star map right here. This is the sky as it is right now. And I'm just kind of pull it up so you can see all of it. There's the moon right there. It's where the telescope is
Mm-hmm.
pointing. You can see the targets there. And then Mars is over here. And then over here to the left, we have a lot of controls. So the controls that I was using to move the telescope are these little arrow keys right here. And then we also have controls for the dome. So if I want to do things like open the dome, close the dome, open and close that big shutter that allows us to look out at the sky, I can use these buttons right here. So this is how we drive. And so I'm going to do some driving around here. Let me get our view of the moon back for you all. So I'm going to change my screen share. And we are going to have another look at the moon, and I'm going to do some driving. All right,
Okay.
let's do some driving. So everyone fasten your seatbelts. We're going to be taking a flight over the moon here. Maybe if I can get my control software back. Oh, there it is. Okay, here we go. Let's drive around the moon. So I'm going to move the
Oh, there we
telescope a little
go.
bit. There we go. You can see a whole bunch of different craters. So right now we're looking along what's called the Terminator. The Terminator, that sounds really kind of scary, I know. But the Terminator it's just the dividing line between night or light and dark or night and day on the moon. And along the Terminator is where the shadows tend to be the longest. And when you have those nice long shadows, that's where you can really see a lot of detail in the lunar surface. So we're going to just keep going down the Terminator. You can even see right here, those craters there kind of up. Let me see if I can adjust our camera a bit. These are some
Oh,
craters
yeah.
right here, right on the far end of the Terminator. Their shadows are very long. They're not really quite fully illuminated yet, so they're a little hard to see. They look a little dim. So we're going to drive a little more, and actually in a minute, we're going to go over and take a look at other parts of the moon. So what I'm doing right now is this little thing called exposure. I'm actually screen sharing the software that we use to control our camera. So when you run a telescope, what you end up doing is having a whole bunch of different software programs running at once. One for the telescope, one for the camera. Um, so you have to basically control different software programs at the same time. So it's a little bit like dancing on the head of a pin. um, So I was just adjusting the camera exposure there. Now we're going to go a little bit uh, away from the Terminator now, and now you can see how things are much more brightly illuminated. We can see some more craters. So one of the common misconceptions about the moon is the best time to look at it is when it's full moon. And that's in some ways true. It's a really cool view when it's full, but it's awfully bright. And also, when the moon is in full phase, we don't have those areas of shadow. And when we don't have those areas of shadow, it becomes harder to see detail. So craters, for example, become really hard to see in full moon. Uh, I actually really love the crescent moon because of the crescent moon, you can see the Terminator really well, and then you can also see something called Earthshine. You might have heard of this as the old moon in the new moon's arms. And this is when you see that illuminated crescent, but then the rest of the moon kind of looks like a full disk. You can see the rest of it very faintly illuminated. What's happening there is that's actually light from the Earth, which is also light reflected from the sun, reflecting off the moon. So yeah, we've done some moving around. I'm going to set the camera again, and let's see, do we have any other questions in the last
Oh,
few
this
minutes?
is a good one. I
Ooh,
love this one. Why doesn't the moon rotate on its axis?
why doesn't the moon rotate on its axis? Well, actually, the moon does rotate on its axis, but the moon also keeps the same face pointing towards us here on the Earth. So why the heck is that? Well, the moon's rotation period is almost exactly the same as the time it takes for the moon to orbit the Earth. So the moon takes roughly about 28 days to rotate on its axis. So it's a much, much slower rotation rate than the Earth, which is, of course, every 24 hours. And then the moon goes around the Earth in its orbit once every 28 days. So because the rotation rate and the orbital rate of the moon are almost exactly the same, the moon effectively keeps its same face pointing towards us. So the moon is rotating, but it's just the way it's rotating makes it look like it's not, when in
I
reality it
remember
actually is.
this was a really hard concept for me to get when I was first learning about the moon. So basically, it was suggested to me to just take a piece of paper, crumple it up, put a dot on it. I would make it a little more fun, maybe put a smiley face on it or something. Have it orbit your head. So have it, you be the Earth, and then have that crumpled up piece of paper or tennis ball or whatever be the moon, and then have it go around your head, but keep the same face towards you. So keep that smiley face or that dot towards you as that object is going around your head. And you're going to find that you're going to have to turn that tennis ball or that crumpled piece of paper in order to keep the same face towards your head at all times. So for your smiley face to see that smiley face as it goes around your head, you are going to have to turn that sphere. So that's a great way to illustrate it to yourself if you're still kind of like, no, not really getting it. Just give that a try.
And if you're confused, don't worry. As Liz said, this is not an easy concept to grasp. It's not an easy concept to visualize. So if you're like, don't quite get this, that's perfectly and totally okay. Um, Very common to struggle with these kinds of thoughts. And even I will sometimes struggle with them as I try to explain things. I'll be like, did I explain that right? So it's tricky to visualize this and get it all in your head. So don't feel bad. Do we have
Oh
any other
yeah.
questions?
No, that looks like it. And we have hit 8:30, so it's perfect timing. Um, Thank you everybody for tuning in tonight. I hope that if you didn't, if you missed the Mars landing, you'll go back and look at some of those highlights on NASA and JPL's website. Definitely tune in for that NASA briefing on Monday. More exciting stuff is coming down the pipeline. And thank you so much once again. You had wonderful, wonderful questions this evening. And I know it's a little bit chilly, but go put on a coat, bundle up, go step outside, look up at the real thing, because nothing beats seeing moon and Mars and all the stars with your own eyes. So definitely go out and enjoy. Any
Uh,
last words, Matthew?
Yeah, I just want to wish once again everyone a wonderful night and stay safe and healthy out there, and we'll see you next week.
We will see you next week. Have a great rest of your weekend, everyone. Bye
Bye.
bye.
See ya.